my name is Pearl, and today I'm going to be taking us through this relatively hard question from the engineering mechanics textbook. The question says if the magnitude of the resultant force acting on the bracket is to be 80 pounds directed along the u axis, that is, the resultant force in this case is 80 pounds along the u axis. Determine the magnitude of F and its direction theta. So just to get a clearer understanding of this, we've been given the resultant force 80. We've been given two component force 90 and 15, but we were not given the value for the third component force. In case you don't know what the component force is, if you're given F1, you're given F2, and this is the resultant force FR. F1 and F2 are what we call component forces. Alright, so moving back. One thing you should know in this case is that the summation of the forces, that's the component forces, in the x-axis is equals to the x component of the resultant force, and the summation of the y components of the component forces is going to be equals to the y component of the resultant force. Now, let us find the x and y components of the resultant force. This is our resultant force 80 pounds. So F Rx is going to be equals to, if we bring this out, we're going to have, this is the 80 pounds, this is 45 degrees, this is the x direction, this is the y direction. So clearly, using SOHCAHTOA, the x direction is going to be 80 cos 45 degrees, and the y is going to simply be minus 80 sine 45 degrees. This is because this is in the negative y direction. Now let us find the summation of the component forces in the x direction. The first and most obvious component force that's in the x direction is the 50 pounds right here. So we're going to have 50. The next component force we're going to tackle is the 90 pounds here. You can see the 90 pounds has its x direction and its y direction. You notice that the x and y are both in the negative directions. So we're going to have negative. Its x direction is 3. It's going to be in the ratio 3 over 5 times 90, plus the third force is right here. And since we don't know it, we're simply just going to write fx for its x component force. It can also be f cos theta, but I'm choosing to write it as fx. Now the result is going to be fx minus 4. Now remember we said we can equate the summation to the resultant force in the x component. So simply going to be fx minus 4 is equals to 80 cos 45 degrees. We simplify this, we're going to get that fx is equals to 60.6 pounds. Now let's move on to fy. Fy, summation of components in the y-axis. 50 pounds has no y-axis, so we can ignore that. 90 pounds has, its y-axis is the direction of 4. So it's going to be in the ratio 4 over 5, remember it's negative, times 90, plus, again, we don't actually know this, so we're going to write fy. Again, you can write f sine y, I'm just choosing to write it as fy. If we resolve this, you're going to have fy minus 72. Now, Let's equate the summation of the component force in the y direction to the resultant force in the y direction. This is simply going to be Fy minus 72 equals to minus 80 sine 45. Input this in your calculator. You're going to get Fy is equals to 15.4 pounds. So now that we have gotten the F and Y, the X and Y components of the magnitude of F is now simply just going to be Fx square plus Fy square. This is because of Pythagoras theorem. If you know X and Y, you can find the hypotenuse, which in this case is F. If you evaluate this, you're going to get 60.6 square plus 15.4 square. You're going to get 62.5 pounds. Now I'm going to scroll down a bit. For theta, theta is simply going to be um tan inverse of Fy over Fx, which is tan inverse of 15.4 over 60.6. Our answer is going to be 14 degrees. So we're able to get the magnitude of F and its direction theta. Thank you. If you do not understand anything, please do not hesitate to ask in the comment section. Thank you.